to Fascinating Frontiers, episode 91, coming to you on June 4th, 2026. Here's your space and science briefing. A meteorite from the Sahara holds the first direct traces of a lost moon-sized world that formed just after the solar system began. The fragment contains isotopic signatures unlike any known asteroid or planet. Researchers date its parent body to within a few million years of solar system formation. The meteorite likely originated from a differentiated world roughly the size of the moon. Its mineral structure points to early melting and core formation. Laboratory measurements show the fragment once sat inside a moon-sized world, whose core and mantle separated before the object was destroyed. Researchers are now comparing the sample against other primitive meteorites to map where this lost world orbited. From ancient solar system relics, we turn to a telescope that will help us understand the universe on its largest scales. The Nancy Grace Roman Space Telescope will lift off on August 30th aboard a SpaceX Falcon Heavy. The observatory will survey wide areas of the sky to study dark energy, exoplanets, and infrared astrophysics. Engineers have completed final instrument checks ahead of shipment to the launch site. A new blog will track mission milestones and share images during commissioning. While Roman prepares to look outward, another long-running mission continues its close-up study of a neighboring planet. NASA leaders discussed recent operations and science results from the MAVEN orbiter during a public live stream. The mission has tracked atmospheric loss at Mars for more than a decade. Data show how solar wind strips gases from the upper atmosphere over time. The update covered instrument health after years in orbit. Future reports will detail seasonal changes in the Martian exosphere. Mars exploration on the surface is also sharpening its aim at ancient water-rich terrain. New mapping shows clay layers at the Rosalind Franklin landing site extend farther than earlier estimates. The deposits suggest a large body of water once covered the region. Scientists believe these minerals could preserve organic molecules from ancient Mars. The rover's drill will target these layers to search for chemical biosignatures. Orbital data from previous missions guided the refined landing ellipse. While robotic missions hunt for preserved chemistry on Mars, commercial networks keep expanding overhead. A Falcon 9 lifted off at 1540 UTC on June 3rd, carrying the latest batch of Starlink satellites from Vandenberg Space Force Base. Deployment occurred into a polar orbit to expand coverage over higher latitudes. SpaceX confirmed deployment of 24 satellites after the Florida launch, with 5 more expected to follow. Recovery of the first stage booster was completed as planned. This flight marks another step in routine constellation replenishment. As satellite numbers grow, so does interest in who will own the companies behind them. The company values itself at $1.75 trillion, ahead of the planned public offering. Proceeds would fund Starship development and additional satellite deployments. This would surpass previous largest debuts in market history. Investors are watching regulatory filings for final share pricing. Back on the science side, astronomers have spotted an extreme system at the heart of a distant galaxy cluster. The pair totals roughly 60 billion solar masses, the largest combined mass reported. A 3,200 light-year wide cavity surrounds the system, cleared by gravitational interactions. The discovery came from deep imaging and dynamical modeling of the galaxy cluster. The system offers a testbed for galaxy evolution models. While some objects are the biggest ever seen, others are unexpectedly light and porous. Drop tower tests at the University of Duisburg-Essen showed planetary simulant material expands under low gravity. The experiments simulated conditions on small asteroids where self-gravity is weak. Results indicate surface material may be less compacted than models assumed. If Earth's gravity were scaled down to that of a 10-kilometer asteroid, a person could jump off the surface and never return. On such tiny worlds, the weak pull allows loose grains to sit almost weightless, so even gentle vibrations or micrometeorite impacts can make the top layer expand like foam. Experiments in a 100-meter drop tower showed that the same dry powder used to simulate asteroid dirt increased in volume by more than 30% once freefall removed its weight. That extra fluff changes how a spacecraft footpad sinks or how a drill bit grips the surface. Yet no one has measured the exact porosity of the uppermost centimeters on any visited asteroid, leaving open the question of whether real surfaces are even lighter than the lab results suggest. Closer to home, the evening sky offers a simple naked-eye treat this week. The gas giant appears 6 degrees below the bright star after sunset on June 4th. Observers in the northern hemisphere can spot both objects low in the west. The pairing offers a chance to compare Jupiter's steady light with Pollux' twinkle. No special equipment is required for the naked-eye view. The geometry repeats on predictable cycles tied to Jupiter's orbit. That wraps today's tour from ancient meteorites to tomorrow's night sky. Next time, keep an eye on further Starlink deployment updates and any new details on the Roman Space Telescope shipment. That covers today's space and science news. Share this with a fellow space enthusiast if you found it interesting. I'm Patrick in Vancouver. See you tomorrow. And before you go, this show is part of the NARA Network, a family of daily podcasts covering tech, science, markets, and more. If you enjoyed today's episode, give Models and Agents for Beginners a listen. Artificial intelligence explained simply, for beginners and curious teens. You can explore the whole lineup at naranetwork.com. This episode used AI voice synthesis of my voice. Editorial selection and analysis are my own.
Drifting softly through